Let's take a look at lack of root penetration. This is my weld right here. The two plates are 0.625 inches thick. And the welder, when they made their root pass, meaning the very first pass they made to join these two pieces of steel, the welder did not get good penetration at the root. This should burn through. Our weld metal should completely join this machine surface. We should have a slight root protruding from here. But in this case, it was a lack of root penetration. And I'm using a 70-degree probe, and we will see what the signal looks like. We'll be able to catch it uniformly from both sides of the weld. And just to give you a visual of it, this is it's an obvious defect. But I'm using a 70-degree probe because the 70 degree is very good for interrogating the root of our weld. And since it's 0.625 inches thick, for my full V, I have my range set at 3.7 inches. That way I catch my root right around mid-screen, and my toe should be right out around full 100% full screen width. But as we increase our angle of our transducer, our geometry diminishes. The lower the angle, the more reflection that we'll get from geometry. So this is 70-degree transducer, 4 megahertz, 10 millimeter diameter. Let's take a look at this thing. This is a clean section of the weld, nothing much going on here. And bang, look at that. That is a lack of penetration. That's a clean, very clean signal because it's a machine. Look at when I rotate, it drops off very rapidly. Hit a perpendicular, good amplitude, slightly move that probe, drops right off. That's a machine surface that we're looking at, where they machined these two plates, and that's the toe down at the bottom, the root down at the bottom of the weld, the land section of that weld, it shows up very well. Very high amplitude, and again, let's run parallel to our weld. We'll see it has a very distinctive start and stop. Gone. And actually, a little signal that we're seeing right there, that's our real root. And then pull back and towards us, same parallel. Very distinctive start and stop. Let's take out some gain. Let me take it to 80% full screen height so we can kind of see the top of it. Gosh, there's 11 dB, 11.4 dB pulled out of my reference. Look how powerful that signal is. It's a real corner trap. Very distinctive plots to the very bottom of the weld. And let's look at the other side. And let me go back to my reference level, or somewhere near it. I'm still 5 dB down, but look at it. See, plots the same way. Plots right down to the bottom of the weld at my part thickness, at my base metal thickness, and distinctive start and stop, just like on the other side. Let me go back to close to my reference level, like I did on the other side. You can see uniform from both sides of the weld. We see the same type of signal. Distinctive start and stop, plots to the thickness of the plate, and as we rotate, rapidly drops off. It's your classic lack of root penetration.